Have you ever wondered how our universe began? How did it go from nothing to everything in a fraction of a second? And how do we know that this actually happened? These are some of the questions that scientists have been trying to answer for decades, using observations, experiments and theories. Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today's topic is, how do we know the Big Bang happened? In this video, we will look at some of the evidence that supports the idea that our universe started with a massive explosion 13.8 billion years ago, known as the Big Bang. The first piece of evidence is the expansion of the universe. When we look at distant galaxies, we notice that they are moving away from us, and the farther they are, the faster they move. This means that the universe is getting bigger and bigger, like a balloon being inflated. If we rewind the clock, we can imagine that the universe was smaller and smaller in the past, until it was a tiny point of infinite density and temperature. That's what we call the singularity, the starting point of the Big Bang. The second piece of evidence is the cosmic microwave background, or CMB for short. It's a faint glow of radiation that fills the entire sky. It's a relic of the early universe, when it was so hot and dense that light couldn't travel freely. About 380,000 years after the Big Bang, the universe cooled down enough to let light escape from the matter. This light has been traveling ever since, but it has stretched along with the expanding universe, becoming longer and longer wavelengths. Today, we can detect it as microwaves, which are a type of electromagnetic radiation. The third piece of evidence is the abundance of elements in the universe. We know that hydrogen and helium are the most common elements in the cosmos, making up about 75% and 25% of all matter respectively. These elements were formed in the first few minutes after the Big Bang, when the universe was hot enough to fuse protons and neutrons together. Heavier elements, like carbon, oxygen and iron, were formed later in stars and supernovas. The fourth piece of evidence is the fluctuations in the CMB across different regions of the sky. These fluctuations reflect how matter was distributed in the early universe, and how it eventually formed galaxies and clusters. In 1992, a satellite called COBE confirmed this prediction by measuring these fluctuations for the first time. The fifth piece of evidence is the gravitational waves that are produced by violent events like black hole collisions. These waves are ripples in space-time that were predicted by Einstein's general relativity theory, and detected for the first time in 2015 by LIGO. Gravitational waves can also tell us about what happened in the very first moments of the Big Bang, when the universe underwent a brief period of rapid expansion called inflation. The sixth piece of evidence is the recent discovery of a giant ring of galaxies that spans 1.2 billion light-years across. This ring is located 7 billion light-years away from us, which means we see it as it was 7 billion years ago. The ring is composed of 9 massive clusters of galaxies that are connected by filaments of gas and dark matter. According to a study published in Nature Astronomy in 2020, this ring is a rare structure that could only form if there were ripples in spacetime caused by inflation. The seventh piece of evidence is the observation of primordial black holes that could have formed in the early universe. Primordial black holes are different from ordinary black holes that form from collapsing stars. They are much smaller and lighter, and they could have been created by density fluctuations during inflation. According to a study published in Physical Review Letters in 2020, these primordial black holes could account for some of the dark matter in the universe. The eighth piece of evidence is the detection of neutrinos that could have originated from the Big Bang. Neutrinos are tiny particles that have almost no mass and rarely interact with other matter. They are produced by nuclear reactions in stars and supernovas, but they could also have been created in huge numbers during the Big Bang. According to a study published in Nature Physics in 2020, these neutrinos could have left an imprint on how galaxies are distributed in space. The ninth piece of evidence is the measurement of baryon acoustic oscillations that could have been generated by sound waves in the early universe. Baryon acoustic oscillations are patterns of density variations in matter that can be seen on large scales across the universe. These sound waves were caused by the pressure of photons and baryons, ordinary matter, pushing against each other in the hot plasma that filled the universe before the CMB was released. According to a study published in Nature Astronomy in 2020, These baryon acoustic oscillations can be used to measure the expansion rate of the universe. The 10th piece of evidence is the estimation of the age of the oldest stars in the universe. These stars are called population 3 stars, and they are thought to be the first generation of stars that formed from the primordial gas after the Big Bang. They are very massive and short-lived, and they could have enriched the surrounding gas with heavy elements. According to a study published in the Astrophysical Journal in 2020, these stars could have formed as early as 250 million years after the Big Bang. These are just some of the pieces of evidence that tell us how the Big Bang happened. Of course, there are still many mysteries and questions that remain unanswered, such as what caused the Big Bang, what happened before it, and what lies beyond our observable universe. But that's what makes science so exciting and rewarding. There's always more to learn and discover. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.